The converse of the Pythagorean theorem is a concept that we use to tell if a triangle is actually a right triangle. So every triangle is a right triangle if the sum of the squares of the legs equals the square of the hypotenuse. So we're going to plug numbers in and we're going to see, hey, is it actually a right triangle? So in this case, I can pick out numbers for A, B, and C and say, hey, is this a right triangle? So let's use our 3, 4, 5 as an example. If A is 3 and B is 4, we know if it's going to be a right triangle, it would have to be 5. So I'm not going to make it 5. I'm going to say, hey, let's say if it's 6. Then is it a right triangle? If it is, then the two smaller numbers, 3 squared and 4 squared, have to be equal to the longest number, which in this case is 6 squared. And since 9 plus 16 is 25, and 6 squared is 36, since a squared plus b squared is not equal to c squared, then this is not a right triangle. On the other hand, if we want to try and check one that actually is, I'll pick one that I know will work. And let's say we're going to say that we have a 10 and we have a 24 and then we have a 26. So here, if 10 squared plus 24 squared equals 26 squared, then we have a right triangle. So 10 squared is 100, and 24 squared is about 576, and 26 squared is about 676, and if you add those numbers on the left, you get 676 is equal to 676. So yes, in fact, this would be a right triangle, and we would have used the converse of the Pythagorean theorem to show that it is a right triangle.